Hi friends, welcome to ACE online program. Today, as a part of your gate preparation from the courtesy of ACE Online Academy, we are going to give the one important topic discussion in the subject of irrigation engineering. Before I start the subject, I want to give one point, to remind you one point. Occasionally they are giving 1 mark weightage. Most of the times they are giving 2 marks to 3 marks weightage. Like some subjects earlier they used to give for 6 marks, now they are giving for 1 or 2 marks. So don't neglect the subject. Subject is very lucid in style, easy to understand, more practical approach. Any problem you can solve with a common sense. Simple numericals are given, and all the 12 chapters of irrigation engineering are very, very easily digestible, easily memorable, easily reproducible. So whether it is given for 2 marks or 3 marks, you can score those marks and keep them in your pocket, ready for your success. That's why to each and every gate aspirant, I advise, don't neglect the subject of irrigation engineering. In 2022, morning session has given for 2 marks, evening session they have given for 3 marks. They may give for 4 marks or 5 marks also, who knows. Sometimes easy subjects, more questions means really in such a situation, getting highest marks possible is always advantage. Why? Because if more questions are given in easy subjects, all the people will be able to do the work, same paper, tough competition will arise, and unless otherwise you get sufficiently maximum marks, you cannot get through. You cannot go to the stage where you want to go. So please remember, not only keeping the aims high, how to develop the strategy to reach that highest goals with the best strategy possible, with the dedicated hard work, with the planned hard work and dedicated hard work, you can get wonders in gate examination. Today, we take one topic, water requirement of crops. The most important topic for all competitive examinations, whether you are writing gate or ESE, must and should question will be from this chapter. That's why I have chosen this particular topic, water requirement of crops. My dear friends, when you take any soil, if the soil is to be said to be suitable for irrigation, 2 properties are important. One property is porosity. Second property is permeability. Any soil which is said to be fit for irrigation should have sufficient porosity, sufficient permeability. Why? Because porosity will indicate storage capacity. Porosity will indicate storage capacity. The water we deliver for the purpose of irrigation, how much water it can store, is indicated by means of porosity. Number of voids divided by, or volume of voids divided by total volume of the soil sample. Permeability is drainage capacity. If the soil is having the moderate drainage capacity, it is said to be good for irrigation. It should not be the medium like sand. Sand is having moderate porosity and higher permeability. So sand is not suitable for crops. If any soil is having less porosity and high permeability, we can't store the water that we want to keep it stored in the soil's root zone. What will happen? Plants may not be able to receive the required water. As a result, the growth of the crop will be not as per our estimation. Either you have to change the method of irrigation from the ordinary check method of irrigation to we may get shifted to sprinkler method of irrigation. If he is asked a question, if a soil is having moderate porosity and high permeability, and you want to go for irrigation at any cost, what method of irrigation do you recommend? Because of higher permeability, it is not possible to keep the soil in the partially saturated state. We will supply the water directly to the plants, that is by sprinkler irrigation. We can say simply, if you feel that irrigation is essential in such a soil, you have to go for sprinkler irrigation, one of the methods of irrigation. Surface method of irrigation, subsurface irrigation, the third method is sprinkler irrigation. Anyway, we are not discussing in detail about the methods of irrigation. We see only about water requirement of crops. कृपया ध्यान से सुनिए. Porosity and permeability are the two important properties which will characterize the given soil, to what extent it is suitable for irrigation. To what extent it is suitable for irrigation. Porosity is indicated by N. Permeability is indicated by K. Please remember this. Keeping these properties in view, it is proved loam is the best soil for irrigation. Please remember, loamy soil is best for irrigation. A mixture of sand, silt and clay. Different types of loams are available: sandy loam, clayey loam, loamy sand, like that. Loam with a combination of sand, silt and clay, no one exceeding 40%. Generally all will lie in the range of 30%, suitable for irrigation. Please remember, loam is the best soil for irrigation. When I say the word, when I discuss about the loamy soil, please understand, moisture content of the soil is important. Moisture content because when I supply the water, let us take a simple cross section of the field. When I keep the plants, the water supplied here or supplied here can be taken by the roots of the plants. Up to this depth, water can be taken by the plant's roots. If the water is available here, this may not be available for the plant's roots. Up to what maximum depth from the ground level, up to what maximum depth the water delivered can be reached to the plants, that is called root zone depth of the soil. In the water requirement of crops, the most important point is water requirement of crops D, that is the root zone depth of the soil. Root zone depth of the soil is defined as that maximum permissible depth up to which water delivered can be taken by the plant, that is root zone depth. Generally, it is from 80 centimeter to 120 centimeter for any of the soil for any crop. Please remember this. When I take such a point, when I take this root zone depth, from the ground level, root zone depth, whatever water I supply, that will be stored in this root zone depth only. Plants' roots are able to extract the water by capillary action. How much water? To give a particular moisture content to the soil, amount of water to be supplied is equal, we know from the basics of geotech and irrigation, S into D into MC. S is the specific gravity of the soil, gamma dry divided by gamma water. D is the root zone depth of the soil. MC is the moisture content of the soil. What is this expression? It is the depth of the water to be delivered to a soil to give a particular moisture content. To say that the soil is at a moisture content of 10%, specific gravity say 1.5, root zone depth say 1 meter. So 1.5 into 100 into 10%, I can calculate very easily. As an example, I am telling 1.5, 100 centimeters, 10% moisture content, therefore 15 centimeters water. What's the meaning of that? When you take the drymost soil, provide 15 centimeters water to that soil, we can declare that the soil is having the moisture content 10%. If the moisture content increases, the depth of the water you have to deliver increases. As we have studied in our basic course, 6 types of moisture contents are important. 6 types of moisture contents: saturation capacity, field capacity, optimum moisture content, temporary wilting point, permanent wilting point, and ultimate wilting point. Field capacity is the safest maximum, OMC is the safest minimum. Whenever, if you take a crop in a given field, whenever you are supplying the water by artificial methods of irrigation, by releasing the water by means of canals, or by driving the water from the groundwater source to the field, whatever is the method of supply, you have to start the irrigation when the soil's moisture content is at optimum moisture content. Stop supplying the water to the field when the soil in the field is reaching the field capacity. Beyond field capacity, non-capillary pores also starts getting filled with water. Necessary air will be expelled out from the soil. Soil is subjected to the danger situation called waterlogging. That's why, as a rule, a farmer should know, never supply the water beyond field capacity. And we have to start at OMC. We should not wait until the last drop of the water in the soil is exhausted. Out of the total available moisture in the soil, if the 50% is depleted approximately, you have to release the water. From 100% to 50%, again rise from 50% to 100%. Supply 50 to 100, taken by the plant 100 to 50. Supply from 50 to 100. So, my dear friends, if you observe this, supply of water every time from OMC to FC, and the use of the water next 15 days, next 15 days, next 15 days, like this we are going to get very easily. You can say this is the first watering, second watering, third watering, fourth watering, like this. Every time we are supplying the water equal to dW. What is dW? Depth of each watering. What is depth of each watering? Depth of the water to be delivered to the field to raise the moisture content from OMC to FC, OMC to FC. So I can calculate what is dW, specific gravity into root zone depth multiplied with final value FC, initial value OMC. Every time, whenever the farmer is ready to supply the water to the field of irrigation, what is the depth of the water to be delivered by him? dW water. dW water must be supplied to the plant. If dW water is to be delivered to the plant, how much water we should deliver at the entry of the field? Should take into account the field losses. How much water shall I release from the canal system, source, reservoir? We should take the conveyance losses. So, we know these things. Please remember this. dW stands for, everybody knows, my dear friend, every time whenever I am raising the moisture content from OMC to FC, how much water shall I provide? If D is in meters, dW will be in meters. If D is in centimeter, dW also in centimeter. And you can get this formula, we can understand this point. Please, this one formula is important. If you look at the figure, today I supply first watering and second watering, time gap is called frequency of irrigation. Frequency of irrigation is also one important formula. Frequency of irrigation. Frequency of irrigation is equal to dW divided by Cu. You are supplying how much water? dW. Plant is consuming every day how much water? Consumptive use, which depends again the capacity of the soil plus plant to release the water in the form of evapotranspiration. Land evaporation plus plant evaporation combinedly called evapotranspiration. By means of consumptive use, the daily demand of the water by the plant is called consumptive use. Every time we are supplying DW water, every day it is consuming CU water. What is the time gap between one watering and the next watering? Nth watering and n plus 1th watering. Nth watering and n plus 1th watering. How much time gap is there? That is called frequency of irrigation. Frequency of irrigation is defined as simply mathematically depth of each watering divided by consumptive use. Centimeter by centimeter per day, frequency of irrigation will be in days. So DW is important. Sometimes he will not give OMC value, he will give at PWP value. Then I told you from PWP to OMC is 50% of this. Recall the basics of water requirement of crops. FC to PWP is called available moisture. FC to OMC is called readily available moisture. If FC to OMC is 50%, FC to PWP will be nearly 100%. I'm just giving an approximate idea about this is called available moisture, this is called readily available moisture. So sometimes instead of giving FC and OMC, he may give FC and PWP, and he can say water is supplied once 50% of the water is depleted. Then FC minus OMC is equal to 50% of FC minus PWP. We can get that point very easily, my dear friends. Please observe this. DW divided by Y is FC minus OMC divided by FC minus PWP. So given as a Y, what percentage I can say? Suppose if he says 50%, DW is 0.5Y. If he says water is delivered, once the 40% of the available moisture is depleted, 40% of the available moisture is depleted, immediately you are supplying the water. So FC minus OMC is 40%. So then DW will be 0.4 times Y. As per the data given in the problem, even it is given in terms of Y, what is the formula for Y? I need not say. Y is equal to S into D into FC minus PWP, permanent wilting point. It is also one useful formula. Most of the times he is giving the questions on this. What are the important points we should remember here? You can see sometimes porosity is not given, specific gravity is not given, porosity divided by field capacity, or otherwise gamma dry divided by gamma water. Any one of the formula we can use for specific gravity. Root zone depth, I know, this is called RZD, root zone depth of the soil for the given crop. Root zone depth depends on what factors? You will ask the question. Type of the soil, type of the crop, stage of the growth of the crop, stage of the growth of the crop. You can observe this point very, very easily. One more point if you observe, when you look at this graph, please see this. From the first watering to the last watering, this is called first watering to the last watering. Let us say it's the last watering. This is called base period. Sowing is done somewhere after 1 week, generally after 1 week after the first watering. Harvesting is done 1 month after the last watering. Then you got here harvesting time, it's a sowing time. Time interval between sowing and harvesting is called crop period. Even though crop period is nearly 10% more than the base period, generally we take base period is equal to crop period in all the numerical calculations except in the situation where the difference is asked. Please understand such points. And the next point you have to discuss here about how much is the total depth of the water required. Delta is standing for total depth of the water to be delivered to the field so that the crop will come to maturity, that is delta. In how many days available, that is base period. And with what duty? Duty of water is nothing but area irrigated divided by discharge, area actually irrigated. Area irrigated divided by discharge, that is the duty. D stands for duty of the water. These three parameters are called most important water requirement of the crop. For what discharge supplied throughout the base period, how much land can be irrigated, that is A by Q, that is called duty. How much depth of the water is required by the crop, delta. What is the time available to supply the water to the field, that is B. Depth of water, time available, and what is the capacity of the soil. By delivering 1 cubic of water throughout the base period, how much land can be irrigated, that is duty of water. The relation between them can be obtained. We know pretty well, very easily, the relation between these three parameters. If delta is in meters, delta is 8.64, B by D is a very commonly asked formula. Numericals are asked when delta is in meters or delta is in centimeters. 864 B by D. In these two equations, B will be in days, B will be in days, B will be area by discharge, area in hectares, discharge in cubic. To convert that hectares, only this conversion factor has come. Please remember the SI unit for delta value. When delta is in meters, 8.64 B by D. When delta is in centimeters, 864 B by D is also one important relation. How do you get this formula? Very, very simple. If you take the simple figure, field of area A, supplying water for Q for a time of B days, plant this soil, the crop in the field requires delta water. How much water is required by the crop? A into delta. How much water is delivered by you? Q into B. If we supply just A into delta is equal Q into B. To take care of the units, you will get any one of the formula you require. Generally in FPS system also formula is there, but generally it is not asked because there is a standard rule, either SI system or CGS system must be followed. Unless otherwise they want to specifically ask in FPS system, generally it is not permitted, but you must remember if delta is in feet, yaad rakhna, delta is given by 1.98 B by D. Even though B will be in days, D will be in FPS system, acre per cubic, not cubic, not cubic. Delta is in feet. Don't remember this formula to the extent possible. These two are important. Check out in the problem. Delta is given in meters or centimeters. Meters, first formula, centimeters, second formula. These are very important formulas we are having in this. Dear friends, if we have an irrigation system, water irrigation efficiencies we should see. It is also one important area where generally questions are asked. For that, let us take a problem. water irrigation efficiencies. We are taking a field, canal system is there, we are taking a source. Source is supplying Q canal, field is getting Q field, plant is getting Q plant for the consumptive use. Reference to the plant, output by input is called water application efficiency. First formula in this regard, water application efficiency is equal to Q plant by Q field. And generally we multiply with 100 to get in percentages. What is the difference between denominator and numerator? Field losses. You can give in terms of discharges. Time is constant, therefore you can write in terms of volume. Volume of the water taken by the plant divided by volume of the water delivered to the field. Volume is equal to area of the field into depth of the water. So I can also give the formula Y plant divided by Y field. Any one of the formula, you can give the problem in terms of discharges, you can give the formula in terms of volumes, you can give the formula in terms of depth of the water. When you want to express in fraction, if you want to express in percentages, multiply with 100. So between these two, water application efficiency. Between the supply and the field, source of the water and point of destination, between them the loss we are going to get water conveyance efficiency. Conveyance efficiency. Water conveyance efficiency is given by Q field divided by Q canal multiply with 100. You can write volume of the water at the field by volume of the water at the canal into 100 like this. If you multiply between the source and the destination, you will get water irrigation efficiency. How do you define water irrigation efficiency? Anyone can say very easily. Final destination is Q plant. Initial starting point is Q canal. Multiply with 100 is water irrigation efficiency. Here to here water irrigation efficiency, conveyance efficiency and application efficiency. Anyone, a simple logic, water irrigation efficiency is equal to conveyance efficiency multiply with application efficiency. It's once asked 20% losses in the canal, 10% losses in the field, 20% losses in the canal, 10% losses in the field. What is the overall efficiency of this system? So 20% losses, efficiency 0.8, 10% losses in the field, efficiency 0.9. So overall efficiency is equal to 0.72. You may ask indirectly like this. If the canal losses are 20%, field losses are 10%, what is the overall percentage losses? 20 plus 10, 30% if you write. If you keep the mark as the first option will be 30%. They will see, they know how to filtrate. They know where we commit the mistakes. 20%, 10%, total 30% ले लिया तो हो गया कहानी. खेल खत्म, gate rank gone. 20% in the canal system, 10% in the field system. So here 0.8, there 0.9, total 0.72. If you supply 100 liters per second, plant will receive 72 liters per second. Loss is 28%, not 30%. Conceptual questions, please understand. Losses in the canal, losses in the field, both are taken, and we get these other types of efficiencies like distribution efficiencies, one, statistical efficiency. If you take along with the plant water, negligible water is kept for leaching, then we will get water use efficiency. Then how much water is delivered, taken by the irrigation, during the irrigation system by prior to irrigation, then it is called water consumptive efficiency. Anyway, they are not necessary. The three important one, application efficiency in the field, conveyance efficiency in the canal system, and overall irrigation efficiency. At this moment, you must understand what is distribution efficiency also. Just one point you please observe. If you see water distribution efficiency, most of you know, but you must understand why it is called statistically. It is defined by 1 minus yd bar divided by y bar multiply with 100. You can write discharges, you can write volumes. yd bar is mean depth of deviation. Y bar is mean depth of absorption. It is a statistical method of calculation. Please observe this. There is a field, as an example I am telling. Here we supply 100 liters per second. Plant will receive 90 liters per second. So I can say from the entry of the field to the location of the plant, 10 liters per second is lost. What is Q bar? 100 plus 90 by 2. So average discharge of the system is 95 liters per second. What is QD bar? Deviation. 195 deviation 5. 195 deviation 5. 90 and 95 deviation 5. Deviation has no sign convention. Deviation, how much either higher or lower, it is immaterial. How much it differs, that is important. 100 to 95, 5. 90 to 95 also 5, not minus 5. Divided by average deviation, I want mean depth of deviation, 5 LPS. Simple formula, water distribution efficiency is equal to 1 minus 5 divided by 95, multiply with 100, that is 90 by 95, that is 18 by 19, multiply with 100, this is 5 times 95, 50, approximately 3, 90 plus 5.4, approximately I will get 95.4%. Just a numerical example I am trying to explain. You can ask, which of the following is statistically based efficiency? Only one efficiency, water distribution efficiency. How do you define? Suppose if every point in the field is absorbing the same amount of water, then there is no deviation. YD bar is 0. Then you are going to get water distribution efficiency 100%. When there is no application loss, you may ask a question like that. When there is no field loss, field may be so small or the distribution system must be so efficient that at each and every point, same amount of water is delivered. What is the water distribution efficiency? 100%. So uniformity coefficient is nothing but this value expressed in fraction 1. So these 4 efficiencies के बारे में you must understand. Eta I, eta A, eta C and eta D, these 4 are prominent. You can learn the other efficiencies also, but the most important ones are these. It is one important area where we can learn. Next we will see one more important concept is irrigation requirement. We know the meaning of the irrigation requirement. Average daily requirement is called average daily requirement of water is called irrigation requirement. At the plant, consumptive irrigation requirement. What is the formula for consumptive irrigation requirement? Average daily requirement at the location of the plant. Plant के लिए हर एक दिन कितना पानी चाहिए CU? Average daily rainfall, how much PE? CU minus PE will give the formula for CIR, consumptive irrigation requirement. Water needed to be supplied minus water available by means of rainfall on that day. And net irrigation requirement, थोड़ा सा leaching के लिए, therefore CIR plus daily leaching requirement, all are in millimeter per day. Remember, irrigation requirement is nothing but depth of the water to be delivered at a given location on the average per day. If you multiply with B, total depth of water you are going to get. If you multiply with F, for every watering, how much depth of the water you, for example, F is 10 days. Every day CIR, 10 days, 10 into CIR. 10 days including leaching, 10 into NIR. At the entry of the field, FIR, CIR divided by eta A. Because CIR is the output value. Output divided by output by input will give input value. And if you want the gross irrigation requirements, FIR divided by eta C or CIR divided by eta A into eta C. So I can give the formula for GIR is equal CIR divided by eta I is also one useful formula. Any one of the formulas, my dear friend, we can use. Just they will give the formulas, they will give the concept on the average per day at the plant, only for plant, at the plant including leaching, at the entry of the field, at the entry of the source, on the average per day depths of the water required are calculated on the heading of irrigation requirements. Whether you take CIR, NIR, FIR, GIR, all are in millimeters per day. One ESC prelims examination, one question is given, which of the following is the correct order? You can say definitely CIR is less than, NIR is less than FIR, greatest value is definitely GIR. You can get the relationship like this. He may give in terms of efficiencies. He may give in terms of CU and PE and CIR. A very, very important concept in the water requirement of crops, dear friends. That is how much water is required at a given location on the average per day, into B, total depth, into F, every time, at the time of every watering. Let us see some numericals before we go to some other concept of the same chapter. Let us go for the next slide. This question is given in GATE 2000. Duty is given, base period is given. What is delta value is asked in what units? Meters. Delta in meters, I need not say. 8.64 B divided by D. Meters. 8.64 into base period, 120 days divided by 1428. You can simplify this value using the virtual calculator. .726 meters. So 0.73 meters is the right option. You will ask such simple questions. Irrigation numericals, only sometimes they will give for 2 marks or questions. Little bit complex, we will see those problems also. But most of the times definition based problems only asked. Let us see one more question. Sprinkler irrigation system is suitable when? I told you steep gradient is available, soil is easily erodible. I can't make the water to store in the soil's capillary pores. because the soil is erodible. I can't store the water in the capillary pores of the soil. So surface or subsurface is not practically possible. I had to go for sprinkler irrigation. This is the correct option. Soil is having low permeability, wrong. High permeability is suitable. Water table is low, is wrong. Crops to be grown have deep roots, wrong. If the soil is having deep roots, any type of irrigation system is possible. So correct option is A is the right option. In this question you can see this problem. Consumptive use of water for a crop during a particular stage of the growth is 2 millimeters per day. Solution, Cu will be 2 millimeters per day. Maximum depth of available water is 60 millimeters and irrigation is required when the amount of available water is, I told you, PWP to FC, total available water. OMC to FC, depth of the water required for irrigation. So he has given total water storage capacity. I want DW. He said 50% of the water is, DW is 50% of water storage capacity. 0.5 multiply with 60 millimeters. You will get 30 millimeters. Depth of each watering is 30 millimeters. Daily use is 2 millimeters per day. My egg bar supply kiya 30 mm. Every day plant will consume 2 millimeter. Every time whenever I supply the water 30 millimeter, it will be consumed in how many days? 30 mm divided by 2 millimeter per day. So what is my frequency of irrigation? dW by Cu. 30 mm divided by 2 mm per day. Simple common sense logic, my dear friends. Mm gets cancelled. 15 days. Frequency of irrigation, he asked 15 days is the right option. You can solve within just, I tell you, within 10 seconds. Take any problem in irrigation, maximum time 30 seconds. With the speed with which you are able to solve in irrigation, if you are able to get the proficiency in all subjects, 65 questions, each 30 seconds, 65 into 30 seconds, 1950 seconds, approximately 33 minutes, just half an hour. 3 hours exam, you can complete a half an hour, you will get All India first rank. Laurels to you, laurels to our ACE Institute, laurels to the country also, to your college where you have studied your basic degree BTech. So you should develop that strategy of how to get command over the subject. What are the important areas? In what areas frequently asked questions are existing? What are the important concepts in that particular subject? You should prepare your own short notes. Whenever it's possible, 5 minutes, you are taking breakfast, just keep the short notes aside. Go through one chapter. Within 5 minutes, you can revise one chapter. The more the number of times you greet a person, the more the bond will develop between the person and you. The more the number of times you greet the subject, such a stronger bond will be developed between the subject and you. Automatically success is yours. Bond should be developed between you and strength of materials, you and FM, you and GTE, you and most important environmental, most important surveying, most important transportation. You know the order. I am not saying any subject is inferior. I am telling with reference to the previous year question papers, we are giving the order of the preference. Topmost geotech, second is environmental, like that I am giving the order. Irrigation lies somewhere, I agree, but it's not the subject that can be left over with. No. You will be in hot soup, tomato soup, if you neglect irrigation subject. Please remember this. Anyway, one example given in the GATE 2007, this question you can understand very easily. See this. An outlet irrigates an area of 20 hectares. This area is 20 hectares. How much discharge is required for this? 20 millimeters. 20 millimeters in 20 days. So CU will be, CUR we can say simply, because discharge is given 20 millimeters in 20 days, I can, neglecting field losses, I can calculate so we will see there is a field area 20 hectares, 20 millimeter water in 20 days, delta will be 20 millimeters, B will be 20 days, duty I can calculate 8.64 B by D, 8.64 into B must be in days 20, D must be delta must be, because 8.64 meters, 20 millimeter means 20 by 1000 meters, 20 cancel, 8640 hectare per cubic. D value 8640 hectare per cubic. I know area, I know duty. Can I calculate the discharge or not? Yes. Discharge Q is equal to A by D. Area in hectares, 20 hectares, divided by 8640, hectare by hectare. You will get in cubic, meter cube per second. I want liters per second. Multiply with 1000. You will get in liters per second. This is in cubic. In terms of conversion factors, you must be very, very fluent, my dear friends. If you are good in simplification, success is yours. 20 into 1000 divided by 8640. 2.3148. Q, so many liters per second. 2.3148. Correct option is B. See how closely he has given the values. In such a cases, for this there is no need of calculator. Why? Because 20 gets cancelled, 8640. Here 0 will get cancelled, 2 will give around 432. 1000 by 432, you will get 2.31 very easily. Or you can use virtual calculator also. Nothing wrong. If you are able to become so self-efficient in solving such simplifications easily, lots of time will be saved. Anyway, such type of questions are asked in gate paper, my dear friends. And see this question. Intensity of irrigation 50% with the command area 50,000 hectares. Command area 50,000 hectares. Intensity is 50%. So actual area is equal to intensity into CCA. Out of the total area available, in how much area you have irrigated actually, that is called intensity of irrigation. He says 50%. 0.5 into 50,000. So actual crop is irrigated in 25,000 hectares only. Let us see the other parameters. Duty for the Kharif season is given. Duty is 1000 hectare per cubic. Assuming transmission losses of 10%, what is the required discharge up to 2 decimal places at the head of the canal? This is my field, this is my canal, it is the head of the canal. Losses are 10%, either evaporation or seepage losses are 10%. How much water is required here? Q field area divided by duty. Area is 25,000 by duty 1000. At this point, Q field, my dear friends, 25,000 by 1000, 25 cumac. I want at the entry of the field 25 cumac. He is asking, assuming transmission losses of 10%, what is the required discharge at the head of the canal? Head of the canal, idhar chahiye mujhe. Output is known. Losses 10% means efficiency 0.9. You can just get the problem solved. Irrigation efficiency is equal to Q field divided by Q canal, 0.9, 25 by Q canal. Q canal is equal to 25 by 0.9, 25 into 1.1111, so on. You will get very easily around 20, up to 2 decimals he is asking. 25 divided by 0.9, 27 points. $27.777 up to 2 decimals, 27.78 cumac. Don't commit the mistake in simplification, and very easily you can get the answer from the fundamentals. What is the question asked? You can see very easily in the problem. See what is the question given to you. See the question. Out of 50,000, 50% is irrigated. Duty is known. When I know duty, when I know the area, I can calculate what is the discharge required at the field. Losses are 10%. I can calculate what is the discharge to be made available at the entry of the canal, at the head of the canal. I can calculate very easily. Answer for the... See, there's nothing in it. Losses are 10%. Efficiency is 0.9. Output is known. You have to calculate input. It's a 10th class, 10th standard definition. Efficiency is equal to output by input. For this canal system, it is the output, it is the input. Can't we calculate? I told you, most of the definitions are practical-oriented, conceptual-oriented questions. Formulas are conceptual-based formulas. Remember the definition, observe the numerical formula, get it solved in 10-15 seconds. In 1 hour, you can complete the gate paper, my dear friends. First believe in hard work. Develop the belief in hard work. Do hard work, you will get. Always this formula will go as a success formula. Let us see. Command area of the canal grows only one crop, that is wheat. Base period is 120 days. Total water requirement is actually delta, 40 centimeter. Canal discharge 2 cumac. How much area can be irrigated? When I know the base period, when I know delta, can I calculate duty or not? Yes. Duty is known, area is known. Can I calculate the area? Duty is known, discharge is known. What is the formula for duty? Area divided by discharge. Once I know duty and discharge, can I calculate area or not? Yes. You can get the answer very easily. First, I want first of all area. Area is equal to area to be irrigated in hectares, which could be area formula. D is equal to A by Q. So A is equal to Q into D. D is equal to A by Q. So A is equal to Q into D. Q into what is D? Delta is in centimeters, 864 B by delta. Because why I have taken 864? Delta value is given in centimeters. Units and combined units, if you observe, you can solve some problems within seconds. Substitute karo, my dear friends. Q value 2, 864, B value 120 days divided by 40 centimeters. 2 will give 20 times, 20 will give 6 times, 6 into 4, 24, 36, 12, 38, 3, 51. How much land can be irrigated? Your answer for the problem, neglecting all laws. Just 2 years back, in one of the sets, it is given for 2 marks. What is the difficulty in that? Only 2 formulas. D is equal to A by Q, definition of duty. Second formula, relation between, I told you, chapter name is water requirement of crops. What is meant by water requirement? In how many days crop will come to maturity? B. How much water is required in total delta? With what capacity? With what capacity means duty. Duty of water, area that can be irrigated by supplying water at the rate of 1 cumac throughout the base period. Once I know these 3 parameters, only to have the consistency of units, that 8.64 or 864 is coming. Otherwise, simple formula. Volume required by the crop, A into delta. Volume delivered by me, Q into B. Simple definition, A into delta is equal to Q into B. That's all. But because this area is in hectares, delta is in meters, Q is in meter cube per second, B is in days. If you convert days into seconds, hectares into meters, 86,400 by 10,000 is 8.64. The formula is coming as 8.64. We are just applying the continuity equation. Relation between water requirement of crops is based on conservation of what basic principle? Answer, continuity equation. Volume of water delivered by the canal, QB. Volume of the water taken by the crop, A into delta. Water supplied is equal to water delivered, water expended. Water supplied by the field is equal to water taken by the plant. You can get the values very, very, very easily. My dear friends, you can understand this question very, very easily. See how much simple the question is given. It is given in gate 20, set 1. Pan evaporation value 100 millimeters. You have studied. Pan evaporation multiply with crop coefficient, you will get consumed to use. Consumed to use is nothing but potential evapotranspiration, K into EP. Crop coefficient 0.4. Pan evaporation 100 millimeters. So 40 millimeter chahiye mujhe. Out of that, effective rainfall 20 millimeters. After deducting losses, of course, rainfall is 20 millimeter. So Cu minus Pe, 40 minus 20. Every time I supply 20 millimeters, irrigation efficiency 0.5. Amount of irrigation water to be applied in the field in that month is dash. This is the field. Here I want 20 millimeter. Efficiency is 0.5. How much water is required to be supplied? Output is equal to, efficiency is equal to output divided by input. It is 0.5. Y field is equal to 20 divided by 0.5. 40 millimeters is the answer for the problem. Correct option. What is the difficulty in this? I know what is the water required. I know out of that how much is the rainfall in that month. CIR not per day, per month, because problem is given for a specific month. All the details are given. Effective rainfall in that month. Amount of irrigation in that month, everything is in the month only. CIR per month. efficiency formula, output divided by input value. Can you calculate amount of water to be applied to the field? Can you calculate or not? Yes. Pyare dost, please remember this. Your basic definitions, basic concepts are sufficient. Like this, you can prepare for all subjects. I request you only to remember one mantra, LCS. L stands for learn. Learn with zeal. Learn with excitement. Learn with dedication. C, compete. After learning, after getting sufficient practice, take part in the competitive examination. When you sit before the computer, before you write the examination gate, first develop the self-confidence. Yes, I got good logic, I got good concepts, let me fight. Then automatically it will lead to succeed. Succeed. Double E is not needed. Learn, L, compete, C, succeed. Other way, learn with confidence leads to success. Learn with confidence, C stands for confidence there. If you have the confidence in you that you can win, you will win. Don't have the overconfidence, develop the confidence, work with the confidence, develop the strategy, prepare the short notes, ample time is there. It's only the month of July. Of course, last week, August, September, October, November, December, January. 6 full months are there, 180 days, only 15 subjects. Each subject 12 marks, 12 days on the average. You can do wonders. When there is a chance to do wonders, if you are not getting ready to do those wonders, we are unfit to take part in the competition. I repeat once again, remember the success mantra, LCS, learn, compete, succeed, learn with confidence, take part in the competition with a good self-confidence and good zeal to win. Zeal to win is important. Automatically success is yours. With this introduction, I say good luck to everyone. Good luck for all your future endeavors. Good luck for your GATE 2023. I wish all the best and have the serious practice. Don't waste your time in non-related activities. For relaxation, after you study for 6 hours, you need 2 hours relaxation. Not 20 minutes study, 2 hours relaxation is not advisable. We will become a laughing stock among our people. With this simple introduction, I take leave from you. Once again, I wish good luck. Thanks one and all, and see you. Bye.